planet Venus is named after the Roman goddess of love and beauty, although it'd be hard to feel the connection if you were standing on the planet's surface. Venus is a terrible, hideous place, with a scorching atmosphere and a surface saturated in toxic metals. The heat and acidity is unsurvivable, and on first glance, it would appear that there's no potential for life on Venus at all. But is that true? Well, let's explore. The most obvious feature of Venus is its truly hellish atmosphere. The planet has experienced a runaway greenhouse effect, and at this point in its history, the average surface temperature is 462 degrees Celsius, or 863 degrees Fahrenheit. Carbon dioxide composes more than 96% of the planet's atmosphere, with most of the rest being nitrogen, with a sprinkling of sulfur. And the heavy volcanic activity lends itself to a preponderance of thunder and even lightning on a Venusian scale. To get a sense of this, consider that Venus has the densest atmosphere of all 4 terrestrial planets, which includes Earth. The atmosphere on Venus is so dense, the pressure on the surface is 92 times that of the pressure at sea level on Earth. The pressure is analogous to being almost a kilometer underwater. Now, Venus is very similar in size to the Earth, being around 81.5% of the Earth's mass and like 95% of its radius. So it has a roughly similar surface gravity. Now, while this is potentially good for life as we know it, you have to counterbalance this against the extreme heat and pressure and chemical composition of the atmosphere. Now, the surface itself, the surface of Venus, is defined by heavy volcanism that frequently reshapes and remaps the crust. There are, however, some consistent geographic features. For example, there's 2 major continents, or elevated land masses that aren't so heavily disrupted by volcanism. These are the Ishtar Terra and the Aphrodite Terra, which are covered in fractures and fault lines. The rest of the planet's geography is a dynamic and frequently changing place, defined by volcanoes, lava flows, and fields of crumbling slate-like rocks and angular plateaus. The surface rocks are flattened because the atmosphere provides ample erosive forces, considering its strong winds and sulfuric acid rains. The surface of Venus as a whole is isothermic, which means that the temperature remains relatively constant no matter where you are. Day or night, it's generally the same temperature. Even differing latitudes, from equatorial regions towards the poles, have the same temperature. This is because the thick atmosphere is so effective at trapping heat that the entire surface and the inner layers of the atmosphere are basically one roiling soup of metal fumes, acids, and insane heat. The only temperature gradient that really exists on the planet is one of altitude. The higher up you go, the thinner and the cooler the atmosphere gets. However, even at the highest point on the surface of Venus, Maxwell Montes, which is the coldest place that it ever gets, it's somewhere around 380 degrees Celsius, or 715 degrees Fahrenheit. So cold is a relative term. Venus also has a relatively weak magnetic field, and it struggles to protect itself from solar radiation. Not that there's a whole lot that needs to be protected in the first place. The upper layers of the atmosphere have molecules that get broken apart and ionized by this solar radiation, so there's a slow but steady burn of hydrogen, oxygen, and helium. This process is likely what led to all of Venus's water being burned away. Venus is believed to have had water in its early history. Now, much like Mars, the data suggests that the planet's early life was defined by much more temperate climates, and it's quite likely that large amounts of liquid water existed on the surface for hundreds of millions of years, if not for multiple billions of years. Over this time period, the UV radiation would still be slowly working on the planet's atmosphere, burning away water and building up carbon dioxide as a waste product that was too heavy to be blasted out of the planet's gravity well. This built-up concentration of CO2 would lead to a runaway greenhouse effect, and to the Venus that we see today. If this hypothesis about the origin of Venus is true, then there's a distinct possibility that life emerged and evolved on the young Venus. But it would have been wiped out almost entirely by the runaway greenhouse effect and the transformation of Venus into a toxic hellscape. If this initial life existed in the first place, and if it was anything at all like Earth life, carbon-based, liquid water-dependent, nucleotide genetics, that kind of thing, then all of that life is long dead. It would have been boiled away eons ago. If there was any remains, then they'd be in the form of fossils. But then again, how likely is it to find fossils in a planetary crust that gets reshaped by lava flows every 300 to 600 million years? I don't think it's that likely at all. Although, perhaps, there's a very, very, very tiny chance that some fossils may have survived in the more stable Ishtar Terra and the Aphrodite Terra. Now, if this is the case, Venus could be an interesting place for future paleontologists, exploring the surface through heat-tolerant robot avatars. Imagine finding the fossils of microbes on Venus, or the fossils of larger creatures. Imagine if Ishtar Terra holds the fossilized remains of some ancient, giant Venusian carnivore. Before I get too carried away down this line of thinking, I want to reiterate how unlikely all of that is. The temperature and surface conditions are just so brutal that I really wouldn't realistically expect a fossil to have been preserved for so long, or to have even been formed in the first place. And this is all assuming that life existed on Venus billions of years ago, which isn't even a confirmed fact. And if it is true, it's assuming that life evolved beyond simple microbes, and given the time span involved, that's highly unlikely. So all of this talk of fossils on Venus is really, really out there speculation. You shouldn't take it as hard fact. Don't tell your friends that there were dinosaurs on Venus. Now at this point, it might seem like Venus is an absolutely lifeless hellhole, and from a coldly scientific perspective, you might think that there's zero potential for life. But this actually isn't true. While the surface of Venus may be totally inhospitable, it's been suggested that there are plausible mechanisms for ecologies of microbial communities to exist high up in the Venusian atmosphere. We know that microbes live in the clouds of Earth, so it's entirely possible that microbes live in the clouds of Venus. When you get above 30 miles in altitude, or around 50 kilometers, you reach a point in the Venusian atmosphere where the pressure and temperature are not just habitable, but comfortable. This is also where Venus keeps its small amount of water, suspended around this altitude layer in the form of water vapor. At 51 kilometers in altitude, it's a balmy 65 degrees Celsius with an Earth-like atmospheric pressure, although it's still a little acidic thanks to all the sulfuric acid and other sulfur compounds floating around. This comfortable region exists for another 8 or 10 kilometers up, at which point the atmosphere gets pretty cold. By the time you get to 62 kilometers in altitude, the air temperature has dropped to around minus 20 degrees Celsius, and that's not really that comfortable. It's around this more temperate region in the atmosphere that scientists think microbes could live and thrive, feeding off of the energy provided by the sun's UV radiation. And there's a fair bit of evidence to support this hypothesis too. For example, hydrogen sulfide and sulfur dioxide both exist at these altitudes on Venus. But what's curious is that these chemicals typically break each other down relatively quickly. So the only way that we'd be seeing them coexisting is if something was actively producing them. Now I should clarify that volcanoes can produce these compounds, and Venus has active volcanoes. But they aren't necessarily the source of this particular concentration of sulfur compounds. The hydrogen sulfide concentrations up at these altitudes are higher than they are near the surface, where all the volcanic activity is taking place. And if all of these compounds were being produced strictly by the volcanoes, then you would expect a simple gradient, with the highest concentration near the surface and the lowest concentration up at the highest edges of the atmosphere. But that's not what we see. We see this band of increased concentration at around 50 to 60 kilometers. Then you have the existence of carbonyl sulfide, which is also produced by volcanoes, but it's also produced by life forms, like trees. Carbonyl sulfide is actually used in some cases as a predictor of life, or as evidence of life, as it's much easier to make carbonyl sulfide through biochemical processes as it is to make it through purely geochemical processes. Now there's a few really interesting details here. The volcanic activity on Venus, while intense, is actually less than that of Earth, and there would have to be quite a bit of volcanic activity to account for all of these sulfur compounds that we see. It's quite possible that there's something else there helping produce them. Another really interesting detail is the lack of carbon monoxide, which should otherwise be produced as the UV radiation breaks down stuff like carbon dioxide. So where is all of this missing carbon monoxide? We don't know, but it's speculated to be involved in the diet or metabolism of possible Venusian microbes that dwell in the atmosphere. There are known cycles of chlorine chemistry that can consume carbon monoxide and oxygen-containing compounds to regenerate CO2. Carbonyl sulfide can be made by binding sulfur dioxide with carbon monoxide and hydrogen. If this is indeed what exists on Venus, then these microbes would necessarily have to be acid-tolerant, sulfate-reducing chemoautotrophs that live suspended in the aerosols of Venus's upper atmosphere, around 51 to 62 kilometers up. They would probably use UV radiation as an energy source and metabolize the sulfur compounds produced in large part by the volcanoes many kilometers below them. If they really do exist and they really do absorb UV radiation for energy, then that would imply that they possessed some kind of pigment that can handle UV radiation and can absorb it. This would actually explain the dark patches and streaks that are seen in the Venusian atmosphere when it's analyzed with ultraviolet wavelengths. We see that there are these big fluctuating regions where a lot of UV radiation appears to be absorbed, but we don't know for sure what's causing that. If it's life, then that would actually be a really suitable factor that would explain the phenomenon that we're currently seeing. This habitable layer of the Venusian atmosphere is also really exciting for future human colonists. Ideas have been proposed to use giant balloons, like blimps, as a way to establish mobile research platforms, and to perhaps one day host permanent habitats. I can imagine rooms built inside of glass domes. The domes keep out the acidic particulates in the atmosphere, but would otherwise allow the occupants to enjoy the temperature and sunlight. Even though Venus is much closer to the Sun, and so is exposed to more solar radiation and sees the Sun as being much brighter than we see it on Earth, this doesn't necessarily mean that the sunlight at this altitude would be prohibitively bright. Because at this altitude, the cloud density on Venus is still moderately high, and so a lot of that light would be blocked or absorbed, but there would be enough light that you could potentially grow food, and that carries really big implications for colonization. As for Venus as it exists today, Venus is still an uninhabitable hellscape, with a boiling atmosphere and a surface that's pummeled by volcanism, tectonic activity, and erosion from the super dense winds above it. If there is any potential for life at all on Earth's sister planet, then it would exist as microbial communities floating in the upper atmosphere, where a delicate chemotrophic ecology can be sustained, with sulfur compounds, carbon monoxide, and UV radiation. But besides this, there really isn't much potential for life on Venus at all.